I'm Abhima Smilan from first BA Physical Science, and the topic I chose for the competition is shift registers. Before moving on to the topic, let's see a small introduction about registers. Registers are nothing but they are a combination of n number of flip-flop to store n binary data. As we know, flip-flop is a basic memory circuit which is used to store binary 1 or 0. After flip-flop, register come into play to increase the storage capacity. So when we combine n number of flip-flop, we can store n binary datas, and this group of flip-flop is generally called as registers. Now let's see what is shift registers. A register which is used to store or transfer the binary data is called shift register. It is named as shift register because it shifts or transfers input to output for each clock pulse. Generally, shift register operate in four modes. The first one is SISO, it's serial input, serial output. The next one is SIPO, serial input and parallel output. The third one is PISO, parallel input and serial output. And the final one is PIPO, which is parallel input and parallel output. For example, if I want to store 1011, I need 4 flip-flop and it's generally D flip-flop. We have so many flip-flop like JK, SR and T flip-flop. We use D flip-flop because the output is just as the input. Whatever the input we give to the flip-flop will be the output of the flip-flop. So I and O are the serial input and serial output of the circuit, and C is the clock pulse, whereas D and Q are the parallel input and parallel output to the respective flip-flops. These input and output determines the mode of the register. Based on the shifting process, registers are classified into shift right shift register and shift left shift register. The register in which the input is given to the leftmost flip-flop and the stored value is getting shifted towards the right is called shift right shift register. Similarly, if the stored values are getting shifted towards the left, it is called shift left shift registers. As said earlier, if you want to store 4-bit data, we need 4 flip-flop. S is the input of the register, C is the clock pulse of the register, D3, Q3, D2, Q2, D1, Q1. Finally, D0 and Q0 are the input and output of respective flip-flop. Q0, Q1, Q2 and Q3 will be the final output of the register. So input is the serial, output is in parallel. So this mode of operation is called SIPO. Now let's see how shift register is operated in SIPO mode. To store 1011, the output of all the flip-flop will be 0 initially when no clock pulse is applied. To start with, we'll apply the least significant bit through the serial input. So D3 will be 1, D2 will be 0 since Q3 is 0, D1 will be 0 since Q2 is 0, D0 will be 0 since Q1 is 0. As we know that the output of the D flip-flop will be same as the input. So during the first clock pulse, the output will be 1, 0, 0 and 0. For the second clock pulse, we'll apply the next digit, that is 1. So D3 will be 1, D2 will be 1 since Q3 is 0 and the other will be 0. So the output will be 1, 1, 0, 0. For the third clock pulse, we'll apply 0 through the serial input. So D3 will be 0, D2 will be 1, D1 will also be 1 since Q2 is 1, and the respective output for these input will be 0, 1, 1 and 0. For the fourth clock pulse, we'll apply the most significant bit through the serial input. So D3 will be 1, D2 will be 0, D1 will be 1 and D0 will be 1. And for these respective inputs, we'll have the output as 1, 0, 1, 1. 1, 0, 1, 1 is the desired bit we want to store. So as we can see, the inputs are getting shifted towards the right. This type of shift register is called shift right shift register. In general, the serial input is getting shifted to Q3, Q3 is getting shifted to Q2, Q2 is getting shifted to Q1 and Q1 is getting shifted to Q0 and Q0 moves out and gets vanishes. As we can see in register, the output of each flip-flop is connected to the input of the preceding flip-flop, and if we continue to apply 4 other clock pulses, the serial input data starts coming out of Q0 one by one. This is due to mere shifting of data available after the 4 clock pulses. And the input is serial and output is also serial. So the operation is called serial input and serial output operation, and the desired data is stored. Moving on to shift left shift register. In shift left shift register, the input is given to the rightmost flip flop and output of this particular flip flop is connected to the input of the second flip flop, and the output of the second flip flop is connected to the input of the third, and similarly the output of the third flip flop is connected to the input of the fourth flip flop. So as we can see that the input is in serial form and the output is in parallel form. So this type of mode is called serial input and parallel output mode. To store this binary bit, we will first feed in the most significant bit in this type of register. So we can see that the result is shifting towards the left, and this type of shift register is called shift left shift registers. The operation of the shift left shift register is similar to that of shift right shift register. The only difference is that the stored value is getting shifted towards the left in shift left shift register, and the serial input is given to the rightmost flip flop. The desired value is getting stored after 4 clock pulses. So this is all about shift right and shift left shift registers operating in SISO mode and SIPO mode. I got these relevant information from the book titled Introduction to Integrated Electronics, Digital and Analog by Vijendran V.